to be sure what is the result. For both, you must know carbon dioxide is important because it indicates the formation of anion carbonate, CO3. Now, travel to the other equation. Note that the first,
all metals carbonates are soluble in water, except what we have, they are insoluble except sodium and potassium or ammonium carbonate, and all carbonates are soluble in acids. Again,
we can say all carbonates soluble in the acids. You have some exception. This exception depending on the carbonate group as sodium, potassium, and ammonium. Take care because tell you this exception what insoluble in the water, in the opposite. So it's soluble in where? Soluble for the acid. Travel at the other equation about bicarbonate. Bicarbonate means what? It means
HCO3, and the ion here is -1, or the valency of this group is -1. What about this one? In this reaction, to indicate the presence of this group, we have the equation here, NaHCO3 solid state, it's sodium bicarbonate, plus HCl in aqueous solution, hydrochloric acid. Give us what?
Give us NaCl, table salt in aqueous solution here. Also, we have a liquid. This liquid about the water and also carbon dioxide gas evolved. But I ask for both carbonate and bicarbonate produce carbon dioxide gas?
Yes, the effervescence takes place, and the carbon dioxide gas evolved, which turns clear like water milky also. So here we have, do we have any type of difference between them, between the carbonate and the bicarbonate radical?
Yeah, there is big difference here. This difference back to the HCO3, CO3, it means solubility. CO3, soluble or insoluble? We said it's insoluble. What about the carbonate? Sure, it's soluble in the water. Now, let's see more reactions.
So here we have another note about what? About the bicarbonate. All bicarbonates are soluble in water. And after that we have salt solution and the magnesium sulfate solution. A white PPT is formed after heating here. Here in the first one in the carbonate we have on cold, but here we have heating. So the salt solution plus magnesium sulfate solution give us what?
Give a white precipitate. This white is called calcium or magnesium or whatever what we have. Take care, bicarbonated produce white precipitate. Let's see the equation. Do it now. As a beginning,
we have NaHCO3 plus magnesium sulfate, magnesium MgSO4. Give us what? Give us here another two compounds. What are they?
The first one, sure, we say sodium sulfate, Na2SO4 aqueous solution. Also, we have another one in aqueous state, magnesium dicarbonate, MgHCO3, all by 2 aqueous. This is the most important one. Do you think why?
Because we have a differentiation here between the carbonate and bicarbonate by this one, or by this equation here. So here, magnesium carbonate, MgSCO3.
It's magnesium bicarbonate. It's good we say that in aqueous solution. Now, by heating, do you think what happened now? When you make a heating here, it gives
a magnesium carbonate in solid state, and we have carbon dioxide gas that produced, and the presence of water here in liquid state that produced by heating of what? Of magnesium bicarbonate here.
It's good to say all of this. What about to travel for sulfite? Sulfite, yeah, there is big difference between sulfite and sulfate. Sulfite, it means
SO3, and the valency is -2.
But I said sulfate, it means SO4, also -2. This -2, it's back to
what? Back to the valency. What's meant by this? We have negative 2, it means this group gain 2 electrons and make the valency of itself by gaining 2 electrons during the chemical reaction.
You must remember all time this negative 2 negative back to the word anion. It's good and great. What about the travel for the first equation? It will be
Na2SO3 in solid state plus HCl aqueous solution, okay, that reacted to each other, forming what?
forming sodium chloride 2NaCl in aqueous state, plus the water for the liquid state. Also, there is new gas here. This gas, sulfur dioxide, SO2 gas. Do you think it's important?
Yes, it's very important to know this.
Important for what?
For the differentiation between this one of the radical of sulfite and sulfate.
Good. What about the difference? This we will know for the next one. Let's see what you do now.
Sulfur dioxide gas. It's
Yes.
evolved here, so which has a very
Irritating for the important smell and turns a paper wet with potassium dichromate. Why and what happened now? Potassium dichromate in acid state, so we say acidified. Also by
bisulfuric acid, 2 green color.
good. Good to say that. Can you write the equation now?
Yes, we
do
have.
it.
We have the equation here. K2Cr2O7 potassium dichromate in aqueous solution plus what? Plus SO2 sulfur dioxide. Again, concentrate very well. Potassium dichromate and SO2 sulfur dioxide gas plus H2SO4. It must be acidified here. You add the H2SO4 to what? To K2Cr2O7 or potassium dichromate here to form what?
To form another substance of potassium sulfate K2SO4 in aqueous state. Also chromate of sulfate. Yeah, it means Cr2SO4 chromosulfate in aqueous state, and we have a liquid all time. We say that this liquid, it will be the water. Take care, my dear, you have 3 molecules of SO2. Take care for the balance. Balance here, very important to obtain the full mark. Take care and concentrate. Now fly to the other one.
After that, we have the salt solution and plus silver nitrate solution. It's another one of these reactions of what? Of this radical. So what will happen here?
We have here directly we say we have white precipitate. White precipitate is formed which turn black by heating. So the important factor for this case, it means
the heat energy here. So we have the reaction without, or it's what? It's formed by heat energy.
so the reaction cannot be without heating. Now reaction start with the reactants Na2SO3, it means sodium sulfite plus 2AgNO3 in aqueous solution for both. The product here will be what? Will be, as you see, the important one.
So here we have Ag2SO3. It's silver sulfite. And we have plus what? 2NaNO3. This is sodium nitrate, aqueous solution. The first one is what? Is solid state. So this is the big difference between them here. The first one is solid, doesn't dissolve in water, and we have NaNO3 dissolve in water as an aqueous solution.
Now, my dear, this reaction for this lab beginning with this material. Acetate, we have a group of acetate. Also, we have sodium sulfide. Now, when you get it with a salt, this is about sodium nitrate and acetate. The reaction start to work with different material as you see. Get a tube and be careful when you add the solution of acetate. This solution, not more amount. You add now
You add lead acetate to this solution, and what will happen here? we have a black color or black PPT that found here or appears to us. Why?
Because the formation of lead acetate, this the black as you see. Get the solution of the sulfite again in the tube with short amount and try to add another solution in aqueous state as you see. Take what you will see now.
Here we have a black color that's changed into violet color. So the violet here, it appears to us clearly. What else about this one?
This reaction also we get sodium sulfide with silver nitrate. It will be precipitate in the black color. When you heat it, it will evolve and boil and produce a different gases. You must know sulfite here is very important because it gives special gases of SO2. Get this reaction now. This reaction depending on sulfide. Do you know this is the sulfide?
Yes, we have the sulfide here. It is big difference between sulfide and sulfate or sulfite. So here, sulfide that end with DE in the last word, in the last part of the word, we have S minus 2 or negative 2. Why? Because it is called sulfide. But the sulfite that end with T and we have TE and this one is SO2. Let's go to see these reactions about this radical.
Don't forget in the same time, all of them are divalent. Look at the equation to tell me about sulfide. Sodium sulfide in A2H in solid state when you add to HCl in aqueous solution. Now, this is the reactants. The product will be, for this case,
we have NaCl in aqueous solution, 2 NaCl or 2 moles of sodium chloride in aqueous solution plus H2S. It is a gaseous state. So H2S, it has the smell of what?
A smell of the spoiled eggs. But I want to ask, we have new gas here. This gas, it means...
It means what? It means hydrogen sulfide.
But for the last one, we have a special gas about...
About what?
About sulfite,
SO2.
Good. There is big difference between sulfite and sulfide. They occur for different gases. Now, see this equation now. What do you see?
So the equation here, we have Na2S, this is sodium sulfide in solid state, plus HCl in aqueous solution. So here, after, don't forget this, we have 2 moles of HCl. Don't forget the balance of each equation. So here, the product will be?
The product, especially we say 2 NaCl aqueous state, and also we have a gas. All time, don't forget the gas. Tell me what is the name of the gas?
This is hydrogen sulfide gas. And the smell is what is spoiled eggs.
It's good to say that. The gas is very important. Fly to this part. What do you know about?
Hydrogen sulfide gas evolved which has a bad smell, turns the paper wet.
Yeah, it's wet. Wet of what? Wet with lead acetate, which is the black color, which we saw it before. So you catch the equation now. Do it and see.
So here the CH3COO by 2 Pb lead acetate in aqueous solution plus H2S. It's the hydrogen sulfide gas. What will happen here? What will you produce here?
I want to see the gas the first, but I haven't gases. I have lead sulfide and acetic acid in aqueous state. This reaction gives black precipitate, black color. So this another important equation to know the anion of sulfide. Fly to the other one.
So the hydrogen sulfide gas evolved which has bad smell and turns the paper wet with the lead acetate to black.
It's good to study all of this. You must know, my dear, salt solution for this type plus new one of silver nitrate solution. Directly, we have a black precipitate is formed. It's formed from what? Silver sulfide. This equation can be written as you see now.
So the equation here, it's sodium sulfide in aqueous solution plus 2AgNO3. What's meant by this? Silver nitrate solution or aqueous solution. The product will be?
The product here depending on the interchange between them. NaNO3, we know it well. 2NaNO3 plus Ag2S. Yeah, that we needed. The color for this bag too.
It's a black color. So
it's good to say this color. And the color, you haven't any gas. You remember the gas?
Yes, we have the gas, it's H2S in the first one, and we have before this, it has what? It has a bad smell that like the spoiled egg. But here we have no gases that appear.
Good. This sulfide, it's important for all reaction. Look, my dear, the difference between sulfide and thiosulfate. Thiosulfate, it has a special formula. It's back to?
It's S2O3.
S2O3. It's wrong to write like this because I talk about anions. Don't forget to add -2. Yeah, this it means all anion of sulfate, sulfide, sulfite, thiosulfate, -2 divalent anions. Now,
the equation here will be what? Will be sodium thiosulfate, and it is solid state. Plus what? Plus 2HCl in aqueous solution. What will happen here? We have a product that appears in this solution. It will be different from the other one. So it means what? It means
2NaCl aqueous state. It's a table salt, we know it well, but in aqueous state. Plus water, H2O, in liquid state, and the important gas start to appear here. This gas is SO2. It means
SO2 means what? Means sulfur dioxide. It's a gaseous state. So here this is the gas that appears in this equation, and the reaction, that's what thiosulfate, it's the special one of these radicals.
Don't forget, you have an important gas for thiosulfate. This gas, sulfur dioxide. Catch another one, my dear. We have S. S, it means what? S, it means?
It means sulfur. Sulfur, it means solid state in yellow color that appears to us in the test tube as a result or a product of this equation.
I want to ask why we have a lot of this sulfur dioxide and the sulfur. This is back to the greatest amount of
sodium thiosulfate.
Sodium thiosulfate, it means you have excess of thiosulfate anion, 2 atoms of S in excess of oxygen. Directly, the reaction will be long and give you different material, SO2 plus S. Excellent, gas and solid. Fly to the other one.
We have sulfur dioxide gas evolved and yellow PPT. Yellow PPT, it's what? Don't forget this, it is a sulfur in solid state as the result of suspended sulfur in solution. Why? Because again, we have the big amount or large amount of oxygen and sulfur that found in thiosulfate group or thiosulfate radical.
It means that thiosulfate all time active. So when you get another solution of salt solution and add iodine solution, this is big difference. Here you must know the brown color of iodine is removed. Why? I want to see that. Can be sure by
this equation. We have the equation, it's Na2S2O3. Again, we have sodium thiosulfate and it's aqueous solution in the presence of iodine. Iodine in aqueous solution also. So here Na2S4O6 aqueous solution, and we have 2NaI. This is the sodium iodide. What about Na2SO4O6 aqueous solution?
The solution, it has large amount of the sulfur and oxygen. This reaction, it's difficult. So you have sodium tetrathiothionate or thiothionate. Good. Thionate here. Now get the other group depending on the nitrate group.
NO3 and the valency here it's -1. Let us see the equation and reaction of this group.
The reaction here is very important. Look at this. You have now sodium nitrate. This is in solid state. When you add hydrochloric acid, HCl, in aqueous state, directly this reaction has important product. Tell me, what is the product?
So the product here is sodium chloride in aqueous solution dissolved in water, and we have HNO2 aqueous solution also. Here we have no gases. That like what? Like the other radicals. So here, what about HNO2?
HNO2, this nitrous acid, this cannot be stay as you see. This will be decomposed by this equation beginning with
H or 3HNO2 aqueous solution, and we have changed into, or this is decomposed into what? Into HNO3 in aqueous solution plus H2O liquid and 2NO, it's nitrogen oxide in gaseous state.
this gas, new gas, it's a colorless gas, 2NO nitric oxide. This nitric oxide, a special gas for nitrite. Now, do you think this is the end? Sure.
Colorless nitric oxide gas, it's what?
It's a changed and evolved and turned
Into reddish brown color at the mouth of what? Of the tube. So we have the equation. Again, we have colorless nitric oxide gas evolved, which turn reddish brown color. What is the reddish brown color? We know this one from previous. So we have what? The reddish brown color is NO2 nitrogen dioxide. So what is the equation?
The equation directly we say nitric oxide is changed by the oxygen into 2NO2 nitrogen dioxide with the important color reddish brown. Differentiate between NO and NO2. After that, you must travel directly to
Salt solution plus the potassium permanganate acidified by concentrated sulfuric acid. The violet color that produced from this reaction, a violet color of permanganate, is removed. So the permanganate, it has a violet color. And this reaction of salt solution and potassium permanganate in acidic medium, it changed the color of permanganate and it is removed. So why?
This is back to the presence this equation. Look at this. You have 5 molecules of NeNO2, it means sodium nitrite, in the presence of potassium permanganate 2KMNO4. This equation till now it's wrong. You must add sulfuric acid to be acidic medium. Directly we have the result. The result after that will be
5NaNO3 sodium nitrate in aqueous solution, and we have another salt that produced here, K2SO4 potassium sulfate in aqueous solution also, and Mn or 2MnSO4 we have manganese sulfate and H2O. So this is the product of this equation.
we arrive to the end. Do you understand the lesson? I think so.
Concentrate with us very well in this information about the lesson. Till we meet again in another session about chemistry. Till we meet again, thank you and goodbye everybody.